Good morning, ladies and gentlemen. Welcome to week 25. That's right, 25 weeks of your SAT math prep sessions. This week's topic will once again be trigonometry and similarity. I would like to apologize for the quizzes last week. I did have a picture missing on one of the questions. If that were to happen again in the future, please tell your proctor and ask them to email me about that mistake so that I can get it fixed. Okay, we shouldn't have that problem though. Again, this is going to be similar to last week, same three basic question types. We will work through those as well. So, on example 1, it says, in the triangle shown, which of the following is equivalent to BC over AC? So again, if we're looking at this triangle, we identify the hypotenuse by finding the side that is opposite the 90-degree angle, which makes AB the hypotenuse. And then the other two sides are named based on one of the two angles. So if we look first at angle A, the opposite side would be BC, and the adjacent side would be side AC. Yeah. The adjacent side would be AC. Whereas if we were looking at angle B, the opposite side would be AC, and the adjacent side would be BC. Now the reason why we're worried about opposite adjacent hypotenuse is because we are looking at a SOHCAHTOA problem here. Sine is defined as being the ratio of opposite to hypotenuse, cosine as the ratio of adjacent to hypotenuse, and tangent as the ratio of opposite to adjacent. So when we're looking at these answer choices over here, trying to figure out which one of these is equal to BC over AC, well, we need to be focused in on, okay, angle A. The sine of that would be the blue opposite over the hypotenuse. So when we're looking at that, the blue opposite would be side BC, which is correct. That is what we're looking for. But the hypotenuse is AB, meaning that that is not the correct answer because the sine of A is BC over AB, and that doesn't match what we're trying to find in the problem. So we go through here and we write out the SOHCAHTOA value for each of them. So the next one is cosine of B, which is adjacent over hypotenuse. That would be the red adjacent side over the hypotenuse. But again, that's going to have the same problem. The denominator is going to be AB, which doesn't match what they're asking us to find in the problem. So that's not going to be the correct answer either. In fact, that has the same value, BC over AB, which is not the correct one. Okay, and as we go through these and we're looking, we need to find the one that's equivalent to BC over AC. So we go through and we do each one of them. Tangent of A would be opposite blue over adjacent blue, and sine of B would be opposite red over hypotenuse. So we go through and we would figure out the values of each of these and see which one is the correct value. And the answer then would be the one that matches BC over AC, which is answer choice C, is equal to the tangent of A. So the tangent of A is the correct answer there. Okay, only one of the four will match. On to example 2. In example 2, it says triangles ABC and DEF are shown. Which of the following is equal to the tangent of A? So we have to recognize that these are, in fact, definitely similar triangles. Because since we know that there is a 90-degree angle for angle F, we can find the value of angle E. We can say angle E is 180 minus 90 minus 29, and figure out that angle E is a 61-degree angle, which means angle D and angle B are congruent. Now, in your geometry classes, you should have discussed how if two angles in a set of triangles are equivalent, the third one has to be. So it wouldn't necessarily be required, but you could do the same thing with the other triangle to realize that angle A is 29 degrees, meaning that angle A and angle D are congruent as well. So we're looking at a set of similar triangles here. Triangle ABC is similar to triangle DEF, which means that because they both come first in the name, that the trig values of A have to equal the trig values of D. So when it says tangent of A, it could be tangent of A or tangent of angle D, either way. So when we're looking at these, EF over DF is equal to the tangent of angle D. That would be opposite over adjacent for angle D, which means A is the correct answer. Now the others here, just so we know what they are, AC over BC, if we're doing this in terms of angles A and D, AC over BC is nothing. That's actually the tangent of angle B, which is not what we want. DF over DE, same problem, that is the tangent of angle E, which is not what we want. And then EF over DE is actually the sine of angle D, which would be equivalent to the sine of angle A, but still is not what we need. So the only one of these that is equivalent to the tangent of A would be the one that is equal to the tangent of D, which is answer A. Okay, it's all about SOHCAHTOA at that point. All right, and then finally we have example 3. This is a combination of Pythagorean theorem, similar triangles, and trigonometry. So we are told the length of AC is 15, and we are told the sine of angle B is 3 to 5. Now remember that sine is opposite over hypotenuse, okay? In SOHCAHTOA, sine is opposite over hypotenuse. So if we're looking at angle B, 15 is our opposite, and AB is our hypotenuse. And that would leave BC to be our adjacent. Now I'm writing an X and a Y for the lengths because we're going to have to find X based on the information we have. We have enough information to find the hypotenuse, X, but the question itself is asking us for the length of side BC. So we'll have to do that afterwards. Okay, so we set up opposite over hypotenuse, which is 15 over X, and that is equivalent to 3 over 5. So that gives us a proportion. We are then going to cross multiply the proportion. So we're going to do 5 times 15, 3 times X, which would give us 75 is equal to 3X, which allows us to solve for X by dividing each side by 3, and gives us 25 for the length of side AB. So this is 25. Now once we know the length of the hypotenuse, then we can do the Pythagorean theorem. To find the value of y. Because the 15 is one leg, the y, which we're trying to find, is the other leg, and x, which we just found, is the hypotenuse. So 15 squared plus y squared equals 25 squared. And we solve that. 15 squared is 225. 25 squared is 625. Subtract the 225 from each side to get y by itself, y squared by itself. Gives us y squared equals 400. And then to get rid of squared, we take the square root, which would give us that y is 20, which is the length of BC. So our answer there would be 20. So we have to use the trig value they gave us to set up a proportion to find a missing side. And if that's not the missing side that we needed, we then have to realize that in every right triangle, we can use Pythagorean theorem to find a missing side if we already know 2 of the 3 sides. Okay, so once again we have a quiz skill check to do. It will be slightly longer than last week, maybe a question or two longer than last week. And again, maybe it won't be. We'll see how it goes. Go over to Google Classroom and complete this week's skill check. Remember that there is a chance several of the teachers are including those in your actual grades, so please do not rush through the skill check. There will be timers, but the timers do not affect your grade. They affect, basically the reason they're there is to help you mentally time how long you should be spending on each question. They're set to 2-minute timers because you have approximately 2 minutes per question on the SAT. So the timers do not affect your score. If it runs out, it's no problem. Take your time. Make sure you get the questions correct. That's what we're worried about. Thank you very much for your time and attention.